know, right? He's crazy.
Okay, hey there. Welcome to Women Build. This is Sandy tonight talking about electrical basics. One of your names I recognize, the other one I don't, and I'll just go over the basics. I'm Tracy. I'm the Director of Community Engagement with Habitat, and I'll be moderating the session. You may be getting feedback on me because it's my computer. I don't know what's going on, but I'm going to put myself on mute and let Sandy take over. If you've got any questions along the way, feel free to unmute yourself to ask questions, and Sandy will pause now and then to ask anyone if they have questions. It's meant to be Q&A and interactive and feedback, so don't hesitate to jump in. If you don't have a microphone, you can also put questions or comments into the chat, and I will relay those to Sandy. So, Sandy, go ahead and take it away.
Hi, I'm Sandy, like Tracy said, and I'll be doing electrical basics tonight. So I have a presentation for you, and then I'll do a short demo at the end, just a couple of little things. So I'm going to start the presentation. Let me know if you have any trouble seeing it. So these are the things that I'll be going over. First, we're going to go over electrical safety, and I will have some checklists that I will send to Tracy with this presentation that she can share with you guys in the follow-up email tomorrow. And yeah, so we're going over safety because electricity can kill you. So definitely want to make sure, first of all, we're safe. Then I want to go over just a basic understanding of your electrical service at your house. And then circuits and wires. And oh my God, I'm so sorry. My cats are going crazy at the moment if you hear them running around. And then I'll go over how to evaluate your circuits, tools needed that you can use for repairs or installations, common issues, and then a short demo. And please feel free to unmute yourself, ask questions, or put them in chat so that Tracy can let me know that there's a question. So let's see. Electrical safety. So you want to make sure that all your electrical equipment is in proper working condition, because that's one of the primary causes for short circuits in your system, is that something's not plugged in properly or the equipment's not working properly. You want to make sure your main power is off whenever you're working on your electrical system. Sorry. And so I can tell you from experience that, when you have your main panel, then if you don't make sure that the right power switches or breaker is turned off, you can cause fires or anything else. So when I first started doing this stuff, the breakers were listed or labeled, and I turned off the one to my room, like the panel said, but I didn't check to see if the actual power was off using a voltmeter. And I went to unscrew the baseboard heater, and I got flames about 12 inches tall. So it was pretty scary. So generally, I just turn off the whole main breaker now, just in case things are labeled wrong. So that's, a good little tip from experience there. Warm and cold power outlets. So sometimes power outlets can be warm, and that can be from overloading, or if there's a short in the circuit, you want to make sure that you double check that. warm or hot outlets signal definite trouble, so you don't want to use that outlet. I always have a fire extinguisher handy for, the example I already gave. And water is a really good conductor of electricity, and it should never be used to put out fire. So always have that fire extinguisher handy for that. Older appliances need to be grounded. So if you've got any older two-pronged appliances, you might want to replace them. And again, grounding, if you're standing in water or the appliance is in water and it's not properly grounded, it's going to shock you. And then if there's any doubt with anything, consult an expert or an electrician. It's safer for yourself and your well-being to consult the expert rather than try and do something that you're not comfortable with. Rooms with running water should be equipped with ground fault circuit interrupters. And so those are just special plugins and circuits that help with additional grounding, especially when it comes to water. Don't use extension cords for long durations of time. They shouldn't be considered a permanent source of power. They're just a temporary usage. So if you have to use one on a permanent basis, you want to look at getting an outlet installed instead. And then always avoid overloading your circuits. So we'll talk about that a little bit more on how to evaluate your circuits and see if you're overloading them. And then, I just put in, don't be a DIY daredevil. Dealing with electrical is not like dealing with drywall. They can be fatal. And, you can't be replaced. So if you don't have the tools or expertise necessary, then call an electrician. So understanding your electrical service. So your electrical service comes in usually overhead or underground from a transformer that is provided from your electric utility. And it comes in with two hot legs and a neutral leg. And they go into your mast and down into your meter, and then from your meter into your panel. And then from your panel, you will have, two hot legs and a neutral that you can use for your power throughout your house for your circuits. And so if your circuit has a hot leg and a neutral leg, which is generally a black wire and a white wire, that'll be 120 volts. And then if you have all three wires, so two black legs or a black and red leg and a white wire, then that is your 240 volts. And that's generally used for like water heaters, air conditioners, stoves, larger appliances. So your light switches and outlets, they use the 120 volt. Any questions so far?
No, I think we're good.
Okay, great. All right. So circuits and wires. So a circuit is a circular path that begins and ends in the same place. So I kind of put this little picture up here just to show you from a battery or from your panel or whatever, it's going to two different items here. You've got your light switch and your light bulb. And so your power goes through your hot wire to your appliances. And then it returns on the circuit through the white wire, which is your neutral wire. So that's kind of a basic of the circuit. And during the demo, I'll show you one that I put together because I just wired up my back shed about 3 weeks ago. So The cables or the wires come in cables. See that right now. I'll show you this too because I have one sitting on my table. So your wires will be kept in a sheathing that's called a cable, and they're color coded to kind of tell you the size of the wire and the amperage that is best for that. And so I put on this page, and you'll get a copy of this, how the color coding works. And the one I have on my table right now is a white. So I've got 14 gauge wire, and it's good for 15 amp circuits. If you're doing underground cabling, you want to use the gray wire, and you can look, they're always gray, but it'll be labeled for the different gauge and amps that are available in that sheathing. So within the sheath is the wires you're going to use, and you'll have a white wire that's your neutral wire. And again, like I said, it's responsible for completing the circuit and returning the current back to the panel. Then you'll have black or red wires that are your hot wire, and that's responsible for carrying the electrical current from the panel to your device or your appliance. And then there'll be a bare copper wire or a green wire, and that's your ground wire. And it's responsible for creating a path to return the current if there's a ground fault. So it's an additional layer of protection. Generally in your house, you'll use 12 or 14 gauge wire, and appliances, you should use the 6, the 8, or the 10. And then of course, over here on the right, I've got a nice little color code of the wires and how those are coded for general use. It's nice because it's standard. So evaluating circuits in your house. So you'd want a piece of paper and a pencil if you're doing this, but I wrote it down really nice so you can refer to this when you want to do it. You want to go to your panel and determine the amperage and the voltage rating of your circuit. So hopefully your panel's labeled well. If it isn't, then you can, work through labeling it by, turning it off, figuring out what's off and what's on, and what it goes to. But you want to read the amperage rating on your circuit breaker. So single pole breakers, which are the 120 volts, those are, smaller, they're thinner. And a double pole breaker, which are the thicker ones, those are the 240 volts. Once you determine the amperage rating, then you want to multiply the amps and the volts and determine your total capacity. And then you want to multiply that times 0.80 to reduce the total capacity by 20%, and that'll give you your safe capacity. So that's kind of the capacity that you don't want to exceed on a general basis. And then you want to compare your safe capacity to your total power demand. So your total power demand is going to be found by looking at the appliances, light fixtures, etc., that are on that circuit. So for instance, I put an example. I have a refrigerator that's 480 watts, a ceiling white light that has 3 bulbs at 60 watts each, a microwave oven that's 625 watts, and Keurigs, believe it or not, use a ton of wattage. So that was 1,500 watts. And so the total of all of those added up is 2,785 watts. So if you look at my total capacity and my safe capacity, I did up above, my safe capacity is 1,920 watts. So I am over capacity for that circuit. So, and that's if all those appliances are in use at the same time. So you have to remember that. And if all of those were in use at the same time, they could cause the circuit to trip or cause a fire. So the recommendation for that would be to increase the capacity or reduce your demand. Any questions on this?
No, that's great information, though. I had no idea.
Well, I'm glad. If you learn anything, this would be it. So, okay. So tools you would need when you're working on your electricity. So, whoop, sorry. Okay. Can't see if there's anything above wire stripper, but a wire stripper or combination tool. So you can buy either one. Wire stripper is nice. Combination tool is just kind of a wire cutter with a wire cutter and stripper in one, but it can't cut through a whole sheath. It usually can only cut through a single wire at a time. So you also will need needle nose pliers, which are great for forming the loops that you need to like loop over the screw on an outlet or something like that. Or if you need some extra help, like moving the wire, because some of the thicker gauged wires are a little hard to move by hand. And so you can use the needle nose pliers for that. You want your circuit or voltage tester to see if your power's on while you're trying to work with things, or if the circuit is actually complete. You want insulated screwdrivers. So any of your tools that you're using with electricity, you want to make sure they're insulated, so they have a coating on the handles. Because if you are touching metal when you're working with electricity and that power was not off, that will go straight through the metal right into you and shock you. So the insulation helps to prevent you from being shocked.
This is Melissa.
Yes. Melissa, did you have a question? Okay. So again, going back to that story of when I had the 12 inches of fire coming out of my baseboard heater, I had insulated tools, and so I was fine. It was just scary. So your dikes or your cutting pliers, and I put a picture to the left, just kind of showing the different types of pliers. So your needle nose, your dikes, your lineman pliers, those are cutting pliers, and then and your wire stripper, just for an example. So the dikes and the cutting pliers are great for just easily, cutting a wire or even an entire sheath of wires. Electrical tape, if you need to tape up an end. Utility knife for cutting your sheath apart. Drill, I put you 5/8 bit. I have used a 1/2-inch bit before too, but 5/8 is generally the standard for drilling through. So if you're wiring a building or something like that, and you need to put the wire through the wall, then you can drill the hole, and that's the right size to drill it through your joists and everything to get the wire through. You might need a ladder if you're working up in the ceiling or up higher. A tape measure is always handy. For instance, if you're installing a bunch of outlets, you want them all be the same height off the floor. flashlight because the power is going to be off, and so you may not be able to see very well. So you want some kind of flashlight or something. Wire nuts and cable clips and staples, and I'll show those during the demo also. And then I put, I think it's 2 pages of just harmless and harmful household issues that you may come across. And then just for your reference. So, you know, for instance, if you've got a loose outlet plug, you want to turn off the breaker, double check for voltage to the outlet using your voltmeter. If the whole outlet is loose, then you can unscrew the cover plate and add some outlet shims until the outlet is flush with the wall, and then it won't be wiggling anymore. If an individual outlet is loose, so like if you plug something in and it falls out or something like that, your outlet is really old and it just needs to be replaced. So you just want to replace the outlet. Broken light switch, again, turn off your circuit breaker. You'll know that it's off because the light will go off. And then using your flathead screwdriver to remove the faceplate, remove the light switch. You can test the wires for electricity just to see if the whole thing needs to be replaced, or sometimes just the wires come loose, and so you can just rewire it. And it's pretty easy to replace the light switch too, just like an outlet. Simple short circuit. Some electrical appliances like hair dryers can trip or short the circuit. So again, you know, using the evaluation of your circuit that we went over, you can evaluate your circuit load. You can reset the breaker. And then if you have repeated occurrences with the same appliance, then it's probably the appliance, not the electrical system. So you want to replace the appliance. But again, evaluate your circuit load and make sure that you're not overloading your circuit with appliances. A cut or damaged extension cord, you can actually like fix these if you want. If you don't want to replace your whole extension cord, you can cut off the old plug, remove the insulation jacket, and then you know, replace that plug part, and then you can buy just the end plug. So it's not too difficult, but I mean, extension cords really aren't that expensive nowadays anyway. So the hazardous ones that you want to look for are flickering or dimming lights. So that could be a sign of poor connection, and it can lead to eventual arcing, which will cause a fire. And so you want to look, you can turn off your breaker and you can look at your light to see if the wires are loose or if they're corroded. So you could replace your wires, you can tighten up the loose wires, or rewire it, or replace your light if it's really badly corroded. And again, you know, any of this stuff, if you're not comfortable with it, call a professional. If your light bulbs burn out very frequently, it could be more serious. You could have a loose connection in the socket or the circuit. And again, that would be one where you can take a look, you know, turn off your power, pull the lights, the light socket, and then just check for loose wires or corrosion. And then pay attention to nearby insulation, because that can cause overheating. If you've got a dead outlet, so it's completely dead and your breaker isn't tripped, you know, there could be a poor connection, which can cause fire or possible arcing. And if the breaker is tripped, it could be due to excessive heat. And the wires could be melting in the outlet. So that's another one. You want to take it apart, take a look at it, see if it's corroded, if wires are melting, if they're crossed, stuff like that. Again, warm outlets, that's definitely a safety concern. And so, turn off your power, take a look at it, or have an electrician come and check your circuit for the wires being corroded or need to be replaced. And I did forget to put in here about knob and tube. I don't know how many of you know about knob and tube wiring, but a lot of older houses have knob and tube, which is dangerous and has to be replaced. So basically they wrap the wire around this knob, like a ceramic knob, or they run it through these little tubes and throughout your house. So if you see like wires wrapped around knobs, like white knobs, or run through white tubes throughout your attic, you're going to want to replace your entire house wiring because they're really dangerous. And then if you have frequently tripped breakers, it's usually a sign that the circuit is overloaded. So you want to evaluate your circuit, see if it needs to be upgraded, or if you can remove some appliances off of that, remove some of the demand. Questions?
Looks like we're good.
All right. Got a quiet group this time. All right, so here we are to the demo part. So I'm going to have my friend Kate turn on the phone, and I'm going to turn off the laptop and do the demo.
Make sure you unmute your phone, Sandy.
Okay.
You've got some feedback there. So is your laptop still? Maybe mute the audio on your laptop.
I did. Can you hear me?
Yeah, there's still feedback there. If you're done with your presentation, you could try turning off the laptop completely, see if that makes a difference.
Okay.
How's that, everyone? Oh, must be okay.
Yeah, that's good.
Okay, good.
All right.
Woohoo!
So yeah, I completely turned off that, and you should be pointing that at me now.
What?
And if you want, you can get closer. So we'll go ahead and start in here. So like I talked about, so this is the cable sheath, and within the cable sheath, we have, and always do this pointed away from yourself. So you'll have paper that surrounds the wire, and then there will be additional paper around your ground wire. And so you can just grab all of that and pull it back. I don't want to hit Kate.
Thanks, Sandy.
and just cut it off. Okay. So, so like I say, we've got our hot wire, which is our black, our neutral, which is our white, and then the copper, which is the ground. And so, and then said earlier, I was talking about lineman pliers. This is great because it very easily cuts through an entire sheath of wire. So let's see, I just want to show a few things here. So this is what we were talking about, the combination tool. And so like it does have a cutter right here in the middle. And then your wire stripper is down here. And then up here is for like crimping or, you know, moving the wire around if you need to. For the most part, I just use the stripper on this tool, and it's very simple. So, you know, you look, generally it's all worn off on here, but it'll tell you which gauge to use. And then you want to do about a 1/2 inch to 3/4 of an inch. And you just hold it tight, move it around, and then pull. And it pulls it straight off. And then you do the same thing for your white wire. And pull that straight off. So then you have your wires ready to, you know, for instance, wire up your new outlet. Okay, and this is where your needle nose pliers are going to come in handy, because you need to create a loop generally. So, I mean, some of these you can, they'll have holes that you can just put the wire in and then tighten up the screw. And some of them will have the screw where you like loop it around. And so I'm going to show that. So you just create your loop, and then you make sure on the back, it'll tell you, and I don't know if you can see that in here, but like it'll tell you which side's the hot side. So this is hot, and then this side's the neutral. And then the green screw is always for the ground. So we're going to slip your wire loop around the screw. And if it's not tight enough, you can actually get in there with your needle nose pliers and get it tighter. But this loop was pretty good. And then just tighten your screw down with your screwdriver. And then you do the same thing for the other side for your neutral wire. Slip that around there. Tighten it up. And then for your ground, do the same thing. Just loop that around. Get it around your screw. And then this one, I, you know, generally will come in here and tighten that up pretty good around that. And then tighten down your screw. So that'll be coming in from your wall, and then you just push those wires into your electrical box, and then screw this into your electrical box, and then put a faceplate over it. Pretty simple. There'll be times that you'll have two. I'm gonna go ahead and just take these off so I can show this. If you have two sets of wires coming in. This particular outlet is pretty good because you can just put like the second black wire here and the second white wire here, and then put the second ground around here also. But if your replacement outlet only has screws on one side of it, generally your hot wire will go on top and your neutral will go on the bottom. And in that case, what you're going to want to do is use a wire nut to branch the wires together. So do that. I'll straighten these out. Actually, I'm just going to cut it off because it'll make it easier. Okay, so it's all of these. And again, just moving this out of the way so I don't cut Kate or myself. Okay, so, in your outlet box, you'll have two wires coming out. And this is because your circuit is going in and out of the box. So it's coming like from the panel and going to the next outlet, light switch, light, whatever. And so in order to complete the circuit, you need to make sure that these wires kind of continue the power. And so in order to do that, you can branch it like so. So you would get at least you would get either just the straight wires, or you would get another sheath of wires. So you can get just the individuals or a complete sheath, and then you want to utilize each one. So we'll strip these. Down each one of them. And I kind of recommend going ahead and stripping both ends before you start doing the hooking up of everything. Further back. Okay, and the reason is because, pulling that sheathing off can, sometimes pull your wires back apart. So if you just get these ready ahead of time, it's a lot easier. So, of course, these would be stripped as well, but I'm just gonna demo this the way it is for time's sake. So you've got your two black wires, and you put these together in the wall, and then your branch, and you put all three of these together, and then you use a wire nut, put them in there and twist it, and this completes the circuit. Twist it on there, and then you do the same thing for your other two. Get your white, your neutral wires, and your wire nut. And then your ground wire. This one's quite a bit longer, so we're just going to cut that off real quick. And that's the nice thing about needle nose pliers is you can cut a single wire with those too. And then get your ground wire up here. Put your wire nut on. So now in your wall, you'll have the wire nuts that are completing your circuit. And oh, see, that one popped right off. Sometimes that happens. It's probably because these are coated right now. So, yeah. So these will be in your wall. You've got your leads coming out, and then you connect them to your, outlet, the single screws. So you'll have your hot wire on top, your neutral wire here, and your ground wire here. And your circuit's complete because they're all wired together. Does that make sense? And if you don't have wire nuts, you can tape them all together using electrical tape. And the electrical tape you really want to have two, because this protects. So if you have to take something out that previously was there, you can use the wire nuts to wire them up and keeps the circuit going. Trying to find the end. Or you can use the electrical tape to coat them instead of a wire nut. It's a little more permanent. I can get this off. Maybe that isn't the end. Oh, there it is. So again, you just put your tape on it, run it around until you don't see any more bare wire. And then I just pull it and it comes off. So just like that. Okay. All right. Also I didn't put this on the list, but safety glasses when you're drilling and stuff like that. So if you're drilling the holes, it's always good to have a pair of safety glasses so you don't get sawdust and stuff in your eyes. So, all right, so now we're going to go out to my back storeroom and I will show you a complete circuit. Okay, so when you're running up a new building, the thing you need to do is plan it. And put a heater in, a sub panel, whatever. So write it all out on a piece of paper. It doesn't have to be professional with the official symbols or anything. This is more for yourself. You want to make sure that you're, evaluating like how much load you anticipate and see, if you want to put things on different circuits. So for this room, I planned out, so I have 4 lower outlets and 1 upper outlet that I put in that faces outwards to, so that I can plug in string lights outside the storeroom. And then I have a light and a light switch and a heater. So when I did my planning, I figured with the number of outlets and the light switch and the type of light I was putting in, I could put all of those on one single circuit. But the heater needed to be on a separate circuit. So, you know, it determined where the sub panel was going to be, and then ran the circuit through that way. So this is where my sub panel is going to be, and we're putting that in next week. And so I left extra wire to wire everything up to the sub panel. And then you follow the circuit. So, you know, it goes in a complete loop. So it goes to one outlet over here, and then it runs up through the ceiling, and then it'll go over to the second outlet down here, and then over to the light switch, and then back up into the ceiling. And this is, you know, where I'm talking about drilling the holes so that, you know, it works without, when I put drywall on here, the wires aren't going to be in the way. Then it goes back to the light switch, and then it goes to the outlet over here, and then to the upper outlet, and then to the bottom outlet over here. And then it completes over there. So it's hard to describe. I mean, I'm hoping you're kind of getting a feel for it. When you're running these wires through the walls and through the ceiling, you want to make sure they're secure also. So this is where, you know, your little staples come in, and it's really easy. You know, you just put it right over the wire and then hammer those in. Another thing to remember is, like, for instance, the light switch up here. So I knew I was going to be putting in a lightweight light switch. So my outlet box, or my electrical box, is a light for lightweight. If you're putting in like a ceiling fan or a heavy chandelier or something like that, you're going to want to have a good sturdy metal box that has braces. So they have them that have braces against the 2x4s in your ceiling. And then again, for the heater, which I have not yet installed because I need to put the drywall in first before I put the heater in. That's a separate circuit by itself, and I just ran that up the wall and back to the sub panel so that can be put on its own circuit. But the box is ready. And when you put these boxes in, they have nails, and you just line them up and you hammer them in. It's really easy. And then depending on where you want your power to come in, I don't know if you can see in there, it's got these little tabs in here, and you just break out which tab you want to put your wire through. So yeah, so that's basic electricity for your house. Any questions, comments?
Any questions from anyone? Feel free to unmute to ask anything, or again, chat if you can't. Nothing? They're all professional electricians, I guess.
Apparently everybody's ready and raring to go to get this done. All right, well, thank you very much. And like I said, I will send the presentation and the electrical safety checklist to Tracy, and she can pass those on to you all tomorrow. And thank you for coming.
Yeah, great. We did get a comment saying thank you very much, very informative. So thanks, Sandy, and thanks everybody for joining. And you'll get an email tomorrow with both the presentation and the video link. All right.
Great.
Thanks. Have a good night.
Have a good night. Bye.
Okay.